section to be online for because it is a graphing section. If you remember on Monday, we talked about rational functions and what rational functions are. So rational functions just basically mean that we have a ratio of one function to another function. And a ratio is a fancy word for fraction. So basically, we're talking about two functions that are in their fractions. They're a function on the top and a function on the bottom. And we want to be able to look at rational functions and kind of figure out, based on the rational, what it looks like, what our graph will look like, and what the domain and the range will be. So let me pull this over to... So in terms of work to do for this section, it's pretty easy. We just want to really make sure that we understand what the rational function is and why it ends up graphing like this. Okay, so I think the easiest way to do this is to jump right in, and we're going to look at number 1, which is f of x equals -4 over x. Okay, so this is a rational function because we have a function on the top, which is 4, and we have a function on the bottom, which is x, and those are both really simple functions. Okay, and so we want to be able to graph that, and then we want to talk about what the domain and the range is. So if I pop on over to Desmos, it's easy enough to graph, right? If I can find Desmos, there we go. So f of x, remember, we just treat like y. Y equals -4 divided by x. Okay, so we get this nice exponential growth. Actually, yeah, exponential growth. And then we have a flipped curve down here. And we kind of look at it and we say, okay, that looks like a nice function. That's great. Let's talk about what the domain and the range are for this function. So if you remember, the domain is all of the x's that are possible for our function. So let me put this here. So if I look at the domain for my function, it looks like I can go forever here, any -x, all my x's are good, right? Everything is good until I get to x equals 0. And then my graph kind of goes crazy, right? It goes off the top or down the bottom. And then all of my x's are good this way after x equals 0. So for f of x equals -4 over x, right? The domain is all real except when x equals 0. Okay, so now let's look at my actual rational equation, right? Why can x not equal 0? I know it on my graph. It shows me x doesn't equal 0. But why, when I look at this, can x not equal 0? Well, it's because my x is down here in the denominator, right? And we're never, ever allowed to have a 0 in the denominator, because if you do that to your calculator, you get undefined, right? You can never, ever divide by 0. So that makes sense that my x could never equal 0, because if I put 0 in there, my calculator is going to go crazy, or I know by the rules of math that that's not allowed. Okay, now the range, so we can figure it out by looking at it, and we can figure it out by looking at the graph, and we can also figure it out by looking at the function. All right, so the range is our y's. So now we're going to switch to range. Okay. The range is our y's. So it looks like we're good on, oops, I didn't mean to do that. We're good on all our y's down here. And then we get to y equals 0, right? Y equals 0 right here. And it looks like we can't make y equal 0. And then after that, we're good for all these y's up here. So the range is going to also be all real except y equals 0. Except, I spelled that wrong, except y cannot equal 0. Y cannot equal 0. Or I guess it should say all reals except when y equals 0 is what it should say. Now, why is that? Well, one, I looked at the graph and it showed me, right? Two is go back to your function, right? F of x equals -4 divided by x. How am I ever, in order to get this equal to 0, right? In order to get that equal to 0, somehow I have to get this to equal 0. How am I going to get -4 divided by something equal to 0? If I do -4 divided by -4, I get 1, right? If I do -4 divided by 0, I get undefined. There's no way I can put a value in for x that's going to give me 0 because I need to multiply by 0 in order to get 0, and I can't do that the way this function is set up. Okay, so really these problems are easy to do. It's really just doing the problems and looking at why does my graph react that way. So that's kind of what this section is about. So let's kind of do another one. So the next one is y equals 8 over x minus 5. 8 over x minus 5. Go back to Desmos. 8 divided by x minus 5. Okay, so here's my graph for this. And let's talk about what are my values for x and what are my values for y. Okay, so again, I'm going to print this off so we can kind of draw on it. Okay, so if I'm talking about the domain of my function, I want to know what x's are possible. So if I look at my x-axis, all these are good, right? Until I hit x equals 0 again, and then I don't have a value, and then all these are good. So I meant to say this last time, I forgot to say it. Here we have an asymptote, right? X cannot be 0. So x cannot be 0, right? So my domain is going to be all real except x cannot equal 0. And again, if I go back now and I look at my equation, if I put a 0 right here, 8 divided by 0, calculator gets mad, not cool, right? So that is one of the spots where it's undefined for my rational function. Now, y is a little bit different, right? When I look at my range, it looks like I have an asymptote for my range. So remember, your range is your y's. It looks like y cannot equal -5. So all of these y's are good. All these y's are good. I get to -5. There's no value there. There's an asymptote, and then it continues on. So my range is all real except y cannot equal -5. Okay, so why can y not equal -5? Why can y not equal -5? Well, let's put it into our equation and see. So our equation is y equals 8x minus 5. So we're saying y cannot be -5. That does not work. So if I put -5 equals 8 over x minus 5, and I add 5 to both sides of my equation, I get 0 equals 8 over x. And this is that problem that we had before. What x could I ever put in there to end up with a 0? Like, I can't put in x equals 0 because that doesn't work, right? I can't put in x equals 8. That doesn't become 0. There's no value of x that I can put in that makes it equal to 0. So that's why we have a restriction at y equals -5. So hopefully this is making sense. Again, easy to plug it in. The harder part is understanding why your graph behaves that way. Okay, next one. We're just getting a little bit more fancy with each one. Y equals 1 over x minus 3 plus 2. Y equals 1 over x minus 3 plus 2. So these are all just kind of building on each other. I think that's what I had. Yeah, okay. These are all building on each other. Hey, Connor. We're in 8.2, problem number 3. All right, so we're graphing this equation, right? This is a rational function, y equals 1 over x minus 3 plus 2. And we need to graph it, which we did. And we need to find the domain and the range. Okay, so I'm going to go ahead and print screen here so we can draw on it. Okay, so here's my pretty graph, right? And let's start with the x's. Let's always start with the domain. So the domain is what x's are true. So it looks like everything is true for my equation, except I look like I have an asymptote right here at x equals 3. All right, so the domain is going to be all real, right? Except when x equals 3. X can't equal 3. All real except when x equals 3. Now, again, let's figure out why that is. Well, if x equals 3, if I plug that in there, right, then this is going to be 3 minus 3, and I'm going to get 1 over 0 plus 2. Can I ever divide by 0? Nope. Can't do that, right? So that's why it's all real except x minus 3. And I know I'm kind of being a little sloppy with my writing here. So you could either say all real except x minus 3, or you could say all real and x cannot equal negative 3. They're kind of, I've kind of been switching between the two. Okay. All right, so then if I go to the domain looks like I have an asymptote right here, right? At y equals 2. So if I just look at my graph, sorry, I think I just said domain, range. If I look at my range, right, it looks like all real except y cannot equal 2. So why can y not equal 2? Well, if I plug it in, it's 2 equals 1 over x minus 3 plus 2. Okay. Subtract 2 from both sides, and I get 0 equals 1 over x minus 3. So we get into this problem again where how am I going to find a value of x to equal 0? Because I have to be able to multiply by 0 to get it. And I'm dividing, and I can't ever divide by 0. Okay, so I think these are pretty straightforward. Let's see. The last 3 are a little bit more complex. We'll just pick one of the 3. Let's do y equals 2x plus 1 over 4x minus 2. I don't think it'll let me just do that. So 2x plus 1 divided by 4x minus 2. Okay. So maybe I'll scroll in a little bit so I can see my grids a little better, right? All right, so it looks like if I go now to, I've graphed my rational function, right? Open it up. If I go to find my domain is my x's. So it looks like for my domain, I have an asymptote at it looks like it's at x equals 1. But that's not quite right. Maybe I need to scroll in. Oh, no. My scale is off, right? This is 1 right here. This is 1/2. X equals 1/2 is where I have an asymptote. Okay. And my asymptote, oh, well, let's just do domain first. Okay. So domain, you're going to be tired of writing all real, right? Except x cannot equal 1/2. So what happens when x equals 1/2? Well, if I plug it into the bottom, I have 4 times 1/2 minus 2. 4 times 1/2 is 2, minus 2 is 0. So I can't have 0 at the bottom, which is why x cannot equal 1/2. Okay, so what about my range? What about my range? So my range is looks like all y's except y also looks like it can't equal 1/2. Okay, so why can't y equal 1/2? Well, let's figure that out. So if I put 1/2 over here as my y, and I have 2x plus 1 over 4x minus 2. Okay, let's pick a value like, if I put in x equals 1, because that looks pretty close, right? Well, actually, I lied. We are saying that x cannot equal 1/2, right? But as we get really, really close to x equals 1/2, hold on a second, I'm not explaining this right. Give me 1 second to think here for a second. Okay. Sorry, I was saying that wrong. So you can see on your graph that the graph is that y cannot equal 1/2, right? When y equals 1/2, we have this asymptote. And you see that in our graph, the bigger and bigger and bigger the number is, the closer it gets to 1/2, but it can never quite get to 1/2. So let's pick a big number like x equals 100, okay, and see what happens when I plug that in. So I have 2 times 100 plus 1 over 4 times 100 minus 2. Okay, so I have 201 over 398. All right, so you can see that 200 over 400 is 1/2. But even if I get to my big number, I'm never going to be able to find a value of x that's going to get me to 1/2. Even if I put in 1,000, right? I'm going to end up with 2,001 over 3,998. So I'm never going to actually be able to get to that value of 1/2. Okay. All right. So that's that. The next section is also a graph section, but I think I'm going to save that for Monday. So if you have a graphing tool, try to bring that in on Monday. But I think that's all we're going to do for today. I think that should be good. So that's it. So thanks for coming today, guys. And I will see you on Monday.